Hello everyone, welcome to learn general chemistry by using video. This video presents on the stoichiometry of chemical reactions and the mole concepts of chapter 4. There are totally about 10 videos that explain the concept under this chapter. The first video of this chapter includes introduction to writing chemical equations. Generally, after completing this chapter, you are expected to achieve all these 8 learning objectives. The first learning objective is write and balance chemical equations in molecular, total ionic and net ionic formats, classify chemical reactions as acid-base precipitation and oxidation reduction reaction, predict the solubility of a common inorganic compounds by using solubility rule, perform stoichiometric calculations involving mass and mole, compute the percentage composition of a compound, determine the empirical and molecular formula of a compound, explain the concepts of theoretical yield and limiting reactants or reagents, and finally you are expected to derive the theoretical yield and percentage yield for a reaction under specified conditions. These are all 8 learning objectives that are expected from you to achieve after completing this chapter. Now, writing chemical equation. What is chemical equation? Chemical equation is a shorthand representation of an actual chemical reaction, and it uses chemical symbols. Chemical equation give us both qualitative, that is the type, and quantitative, that is the amount of reactants and products. It saves a lot of time and words while communicating. There are some general form of writing chemical equation. To write chemical equation, you write reactants before the arrow and the products after the arrow. Before going to explain this, let me conceptualize the chemical reaction with the bicycle shop and the combustion of the charcoal. For the production of a bicycle in a bicycle shop, we need 2 wheels and 1 frame to produce 1 bicycle. These 2 wheels and 1 frame are considered as the raw materials to produce a bicycle, and in the chemistry concepts are considered as the reactants, and the produced bicycle is considered as a product. Similarly, in the combustion of charcoal, when charcoal is burned with oxygen, it gives carbon dioxide. This charcoal, that is carbon and oxygen, with the help of heat produces carbon dioxide. Carbon and oxygen are considered as reactants, while the produced carbon dioxide is considered as the product. So this is an example for the chemical reaction, and the form of writing chemical equation. You write the reactants and then products. There are some symbols that are commonly used during chemical reaction. The first symbol is the plus. This plus means it separates 2 or more formulas. The arrow means that reactants react to form the products. S stands for solid, L stands for liquid, G stands for gas, Q stands for the aqueous, and this symbol above or below the arrow means that reactants are reacted with involvement of heat. So this is some symbols used in chemical reaction, and the reactants are substances that undergo chemical reactions, and these reactants are written to the left or starting of the arrow. Products are substances that are generated by the chemical reaction and are written to the right side of the chemical equation. As an example, if you see this chemical reaction, this substance and this substance are written in the left hand side of the chemical the arrow, so they are considered as the reactants. But these 3 substances are written in the right hand side of this arrow, so they are considered as the products. But some students are confused with identifying reactants and products of a given chemical reaction. If you see these 2 reactions, the first reaction is very simple. From this reaction, if you are asked to identify the reactants and the products, it is easy that hydrogen and nitrogen are reactants and ammonia is product. But some students are confused with this chemical reaction, and they say that this is product and these are the reactants. But this is wrong. Always those substances that present before this arrow are considered as reactants, and those substances that present after the arrow are considered as the product. So this is reactant, not product. This and this are the products. This is the way of identifying reactants and products from a given chemical reaction. Then the next one is the ways of writing chemical equation. To write chemical equation, some may write in the form of word, or some may write in the form of symbols or using chemical formula. As an example, by using word equation, hydrogen plus nitrogen, it gives ammonia, or calcium carbonate plus sulfuric acid, it gives calcium sulfate plus water plus carbon dioxide. This is the way of writing chemical equation using word equation, and this is the way of writing chemical equation using chemical symbols and formulas for the above word equations. Additionally, magnesium burns in the oxygen to form magnesium oxide. This statement can be written as in this chemical symbol and chemical formula. So this is the way of writing chemical equations. Another thing is the role of coefficients and subscripts. What are coefficients and subscripts in chemical reaction? For example, what is the coefficient and subscript in this chemical symbol and in this compound for hydrogen and for oxygen? As you know, the first one is this 3 is coefficient for the hydrogen, and this 2 is subscript for the hydrogen. Similarly, for this compound, 2 is the coefficient for this water, and 2 this one is subscript for only the hydrogen but not for the oxygen. And oxygen there is 1. This is already known. Another thing is for this chemical reaction, water, to produce water we need hydrogen and oxygen, and this indicates that there are 2 moles of hydrogen, and this 2 subscript indicates that the number of atoms. Another thing is coefficient and subscript both represents the relative number of reactants and the products, and the coefficient is the numbers written in the left side of the symbol or formula on the left side, as we have seen from this. This is a coefficient, and they are used to balance chemical reactions. But subscripts are numbers written in the right side of, like this, in the right side of symbols or formula. They are not used for balancing chemical equation. This is all about the subscript and the coefficient. Another thing is additional activity, that is complete and balance the following chemical reaction. You are expected to complete the products of this chemical reaction and balance the chemical reaction, and write a balanced chemical molecular equation describing each of the following chemical reaction. This is the statement form, so you should change into the equation form challenging. And now from this element X, that's the green one, this one, and Y, that's purple, this one, react according to the following chemical equation. X2 plus 3Y2, it gives 2XY3, which molecular sense represents the product of this reaction. This is expected from you. So this A, B, C, D are given as an alternative. Thank you for watching today's lesson. Thank you. Bye bye.